I'm Roberto Verdecchia from the University of Florence, and I'm going to present a little crash course on how to do literature reviews. This is, I guess, more or less everything you need to know about literature studies, and it's not rocket science. I guess you'll follow quite easily, but just as some warning, this lecture is structured more or less interactive. So I know the Dutch crowd is quite interactive per se, but I did this lecture in different places and sometimes you need to poke students more. I hope this is not the case here, but no worries, I will do it. And you should ask questions as well, right? So whenever something is not clear, and I'm not perfect either, so there might be a mistake here and there. So please feel free to intervene. You're not interrupting, you're just enriching the lecture. This is a safe space. I'm not judging you at all. I will leave to Italy in like 2 days. You'll never see me again, probably. So no worries about that. And maybe the other people who are like more senior here, academically wise, won't be your supervisor as well. So, you know, get weird with it. I'll use low resolution meme to get the message through because I can. And also I'll use a lot of AI images generated. It was back in the day when ChatGPT didn't take over yet, so it generated with DALL-E, but whatever. So what I'm going to present today mostly is a custom literature review approach, which was refined over many years. It's conceived to be quite lean, simple to be used, especially in your case where maybe you have to do something quickly and get results out of them. And it was refined over many iterations of conducting literature reviews and teaching literature reviews. And if you have any feedback at any moment in time, you can just mail me. You'll have the contact at the end of this lecture. And just to give the proper praise, I didn't do it alone. Patricia, a long time ago, I checked, it was like 10 years. I did a literature study and then I liked it, and I'm still continuing to doing that. You know, everybody has their own hobbies. This is one of mine, I guess, between hobby and work. Let's put it that way, academia. Okay, so just quick word on why I am doing SLRs. My first ever published research was an SLR. Which was, I guess, in 2015, so 10 years ago exactly. And from then I did a lot. Oops, sorry. A lot. These are not even all. Again, everybody has their own hobby. This is why I'm talking about literature studies today, I guess. I have a bit of experience in them. Working with different people, and I present this approach. Usually with all these researchers, I basically had a quick rundown of this approach that I'm presenting today. So trust me, it works. This is all published research, and some of them also quite popular. I was also TA of the course for a long while for this course. So I'm back to Italy, but here I am again. With this presentation for, but just to give you a bit of the broader context, it's both for you who maybe don't even know what a systematic literature review is, but to give you a bit the broader picture, it's also presented to other people who have their own approach to discuss it and whatsoever. I guess most of you fall under the first category though, in this specific case. Motivation could come up with a few. The first one is you have no idea of what an SLR is. And so here you are. I hope at the end of the lecture you'll have a good idea and understanding of what it is. If it's not, you can just come chat to me. I'm happy to explain whatever. And again, pose questions whenever you have one. Or maybe you need it for your thesis and you need to find sort of the research gaps to studying a bit the literature and whatnot. And so there's also an approach that can help you in many situations, also in the future, if you stay in academia or if you go to industry and need to have a quick rundown of whatever was written on a topic. This is an approach that you can use in those cases. And again, this is also for more experienced researchers who use SLRs. They can sort of compare their approach with ours. There are many types of literature studies. I think Elias before asked, can you also do a non-systematic? Yes, you can. There are many ways in which you can study the literature. We will focus primarily on one, which is the most hardcore systematic way of studying the literature, but I will also give a glance of other ways of doing a literature search, for example, for this course. For example, you could just have a study some papers in depth. So maybe if you are more into theoretical computer science, concurrency, algorithms, I don't know, then you could have just a few papers that you have to study really in depth, theorem after theorem. And this is one way of studying the literature as well. Then you can have a paper summarization. So maybe you're not searching for papers independently, but rather your tutor says, these are the 10 papers you need to know, and you will just summarize them. And then there are systematic literature reviews and mapping studies, which is what will be primarily covered in this lecture, and is how to systematically analyze a field of knowledge, basically, based on what was published on the topic. All clear so far? Okay, so what is systematic literature review? Broadly is hunting down for specific literature. So you go outside in the real world and you check which papers you really have to hunt down, you analyze them and you report the results. The other type of study I mentioned is a mapping study. And in this case, you don't have a target focus for your literature search. It's more you just stumble around on different topics and say, oh, this happened as well in the field of, we'll have a working example about green AI, for example. You can say, okay, I don't have a real question to be answered. I just look what is out there, basically. And so it's a bit less systematic, and it's called a systematic mapping study. So you generally map a field of knowledge instead of answering specific questions. So just to have it written down, a systematic literature review usually is carried out on, right, there's gonna be a quiz at the end, so you better with prize at the end of the lecture, so memorize as much terms as possible because they might come back or not. So systematic literature review usually considers a specific field which we already know a lot about, to put it in simple words. And usually these types of study start from a predefined goal. So you want to see what algorithms can be used in a concurrency setting with Kafka, I don't know. And so then you can really target that goal, and you have specific research questions you want to answer, and you analyze each paper you find in depth. On the opposite is the systematic mapping study, which is done on a field which is not already consolidated. So it's an emerging field. You just want to understand basically what's going on, what is the current state of the art of a certain topic. And for that, it's better to use a mapping study where you don't have a predefined goal. You just basically map what is out there. It's like, oh, look, in the field of concurrency, this many research papers use this algorithm, or a variation of this algorithm. Yes. So if basically you have to start from a blank state while doing a mapping study. Interesting question. I don't think it's really necessary, also because a lot of papers use a bit of a jargon, which you have to be accustomed with. I don't know if anybody used ever bracketing, which is a technique where usually you do it more for qualitative studies like ethnographies, where you basically note down your assumption on the field before doing the research, and then you report it so that people can see, oh, this is more somebody who has experience with high performance computing, so maybe he's looking at this topic under this lens. But I don't think you need to necessarily start for blank state. Actually, I wouldn't advise it. You know, if someone does sociology, it wouldn't be more fit to do a study on software engineering, for example. Sure. Thank you for the question. What is a literature review? Right. General term, literature review is both systematic mapping study or systematic literature review. It's just the confusing academic jargon that you might hear, but if someone says, yeah, if I did a literature review, it can be one of the two, just to avoid any confusion. And what is a secondary study? What do you think is a secondary study? Not a primary, okay. Is it a systematic mapping study or an SLR? Both. You sure? Yeah, it's well. Really well. Hmm? Yeah, that's what I wanted. um, uh, what do you think they call secondary? It's not. It's quite trivial if you think about it. What could be a primary study? Elias, no, you can't. You know it. No ideas? Wild thoughts? I only have one prize, unfortunately. Otherwise, whoever tells anything wins a prize. We just have one prize for the end. Yes. What do you? How do you mean? It's like the second study about something. Yeah, I'd say close enough. Yeah, thank you. So in general, a primary study is whatever basically does research. So secondary studies just study other studies. What? You get it? So as you have basic research, like let's see if this algorithm is good for concurrency. And there are a lot of these types of research out. And then a secondary study studies these type of studies. So that's why they're called secondary studies. I know, confusing, right? Now I'm going to confuse you even more because before talking about primary study, I'm going to talk about potentially primary studies. So in generally, primary study is ground research that is out there, and a secondary study studies this type of research. A potentially primary study is something that might be included in a secondary study, but you still are not so sure of. So it could be you found a certain paper, but maybe it fits the topic, maybe not. And that's a potentially primary study. It's a candidate for inclusion, let's say, in your secondary study. A primary study instead, and this is a bit of the jargon I have to introduce about literature studies. A primary study is a paper that has been selected for inclusion in your secondary study. So you're sure this is a paper I will include in my literature study and I will extract data from it, and it's fixed. I guess you know a bit now what a primary and a secondary study is. We're going to use a working example during this lecture, which is a study I did a while ago on green AI. Just be warned, voice leap off. And we'll take examples from here and there. So if there is a concrete example, this is all actually real data, which is in that paper. So if anything isn't that clear, you can just go back and look at what is written there, and everything, I hope, is neatly reported as a guiding example. And now we start with the different steps which characterize a systematic literature review. This is more or less the overall process. Just, again, not overcomplicated, just so simple and neatly designed rules. So you start with automated initial search, which you do on a search engine, such as, for example, I guess everybody knows Google Scholar or Scopus or Web of Science or so. Then you apply a certain number of selection criteria. So this is the process where you pass from a potentially primary study, which you get in the first step, to having the primary studies. So you select basically the studies you want to include in your literature review. Then you do the snowballing, which is a process with which you can get more literature, which you didn't find with the automated search. Then you extract data from the paper and you write your final report. The automated literature search. This is usually where you start with finding the potentially primary studies, right? And again, not rocket science, is used to identify the potentially primary studies and how, well, you just search on a search engine. You have an automated query, find papers that include green AI in the title or whatnot, on one or more digital libraries. Then you merge the results and you have your set of potentially primary studies. And common sources for this are Scopus, Web of Science, IEEE Explorer, or Google Scholar, which we actually recommend even if the results are a bit more dirtier. So you might find some gray literature, so literature which is not really peer-reviewed or master thesis or who knows what. So this implies a bit of manual work in selecting really the papers which have a proper level of quality and adherence to the topic you want to investigate. I don't know if you have licenses for all of these. Yeah. Okay. Sorry, water break. This is usually how you can search. Each search engine has their own custom hidden way of executing queries, which is just not typing in words and hitting enter. And it can have things like, find articles with all the words or with the exact phrase, with at least one of the words, etc. There is not one unified interface. Each one has their own, and usually all these search engines allow for a more formal query formulation, which includes some Boolean operators like and, or, again, not rocket science, or in title. Usually for a scholar, we just use in title or and some parentheses put in there to make everything flow nicer. And we'll see an example of this right away. But I suggest to use this type of queries instead of relying on a specific interface like this one, because then it might be hard to be repeated and reported, and maybe you don't even know what all the fields do. So the first step after you selected a search engine, and then again, Scholar works well enough, but you can ask then your tutor if that's the right choice or not. Next step is to formulate the query. Formulate a search query. Some tips here is, again, make use of the query syntax like and, or, in title, parentheses. We'll see an example then. Then split up the query in semantic parts. So maybe you want to look at concurrency in high performance computing. Then the two semantic parts might be concurrency and then semantic computing. And then maybe it's not concurrency, but it's multi-threaded. So use some synonyms to get as much literature as possible regarding that topic, right? And by splitting up in semantic parts, it's easier to find synonyms and then use the and, or to compose it and see what the query is doing. Carefully justify each keyword. It's quite trivial, but just don't put random words in there because you think they're nice. You really should engineer a bit the query in a way that it makes as much sense as possible. And again, Occam Razor, I don't know if you know it, but it's basically among different solutions, the one which is simplest is the best one. So strive also for simplicity, right? Which is not always easy, but it's the most elegant solution and the one which also works best, both from an execution point and understanding also what is happening. And then make many trials. So it's not just you have a query and you say, okay, this is it, done, but make many trials and iterate over the query, remove, add synonyms, remove, add keywords, new ones, and you will see how the results change, both in terms of number of hits and the quality of the papers that you get returned. So maybe you see at some point that your query on high performance computing is getting papers on agriculture because maybe there was a word synonym that works also for agriculture. You should engineer your query in a way that these types of papers are excluded as much as possible from the start. So, for example, yeah, exclude unrelated synonyms, which maybe are common in another field of research. And then after many trials, you can then select the query which is best fitted according to both number of hits. So if you get 1 million hits, it's not a good query because you won't be able to look at 1 million research in like years. And also the quality. So if in the first page of Google Scholar, you see that there are already papers on agriculture, then maybe the query is not so good and you want to refine it another bit. Power tip, yeah, you have to watch out to tune your query in a way that you get a reasonable number of hits. I won't say 150 is good because it depends. But again, right, if you get multiple thousands, then maybe you want to refine your query or even go back to your tutor and say, hey, this is too big of a field. Maybe you want to scope it down a bit in a way that the number of potentially primary study is reasonable to be inspected, right? And this is the fundamental place where you tune the workload that you'll have to do. And maybe 10 is a bit little, but then 1,000 might be already too much. Again, there is no, I'm not saying like 150 is good because it depends, but it's something you can then discuss with your tutor if you're going for a systematic literature review. I talked too much, so now it's your turn. Thinking back on the example of green AI, so we want to look for all the literature which regards sustainability and AI, basically, the sustainability of AI. And I want to build a query for it, which could be a good query. Then we'll see what I really used, but you can use and, or, in title, wildcard. Those are the... Yeah, sure. Can even pass you the mic so I don't have to repeat it.
Why do you call it automated literature search? What would be a manual search?
Very good question. I guess everything is automated nowadays, isn't it? Yeah. Oh, fascinating. Yeah. Terms have changed. I guess this is a legacy term that, who knows, maybe once upon a time, people are going to the library. I don't know. You find it in the literature, yeah, but this might be a legacy term for sure. Nice, good catch. Thank you, Marcus. So query formulation. First step is dividing in semantic parts. Which are the semantic parts here? Semantic, I don't know if you know the term, but it's something which holds meaning. Like a plus per se, it's like not that. Semantic is more syntax, how you structure the language. Semantic is like, oh, this is a concept. Green and AI, yes. And here we have the semantic parts on which we can build on. So now what's the next step? Yes. Things you want to exclude from your query? Yeah, you could do that. Right. Yeah. So basically you want to make AI efficient, but not AI that makes things efficient, right? Yeah. Which might be hard to include in a query though, I think. But we will come back to that in like 2 slides. No, I completely agree with you. We don't want those, we didn't want that kind of paper. And maybe later on you will intervene because the intuition is very right. We didn't realize at the time on executing the query I will present, but what am I presenting for you? Spoiling all my slides. Yeah. So we have then the selection criteria, which will work in that regard, because from the query point of view, we weren't able to exclude them. But maybe since you're bright, you have a way to exclude it in a query, but at the time we didn't found a way. But so we found the two semantic parts. What you can think of building a query which is not just green AI. Yes? Synonyms, exactly. For example, yeah, exactly. And this is why it's in a more structured kind of process. You divide in semantic parts, and then that's just for the synonyms, right? So then you can say, okay, but maybe not everybody uses green, they use sustainable, right? And maybe it's not AI, it's ML or deep learning or who knows. And that's how then you construct a query. So this is basically what we came up with. There isn't a perfect query, right? We're doing engineering at the end of the day. So it's more like hand waving a solution which works first. This worked for us. So we looked in title. So the title should include green, because a lot of people are using it, and then sustainable, whatever there is, sustainable, sustainability, and so on and so forth. And the second semantic part of the query is then anything related to AI. AI, ML, artificial intelligence, machine learning, or deep learning. I guess we could have a DL there, but maybe there was a false friend of sorts, and DL was something that had to do with chemistry or whatnot. And that's why, again, it's not, you can say, find 3 synonyms, then the acronyms of that, because you don't know what the results will be in the end. So that's why also it's a bit of a heuristic process. So you refine the process as you go, you try, you see 1,500,000 hits, it's like, no, you want to redo the query again, till you find something which is reasonable and works for you. All clear so far? Okay, good. You shouldn't download manually the results that you get from Scholar or from Scopus or whatever platform you're using, because that's extremely tedious, and I hope you have better things to do with your life. So there are tools that automatically scrape these websites and give you a neat list of results in a CSV, so in a tabular format, and then you don't need to copy paste stuff. The one I use always is Publish and Perish. I think it works really well at the time of talking. Maybe in 2 years it's gonna be terrible, but for now, Publish and Perish works extremely well. You can execute the queries on different digital libraries directly from the tool. You can merge the results. You can download them as CSV. It works great, and it's free. Yes. No, it doesn't store PDFs, because it also depends on licenses, if you have access to the certain URL or not. And this is actually a tip maybe I forgot to tell, but thank you again. And this is why it's important that you intervene as much as possible, because it helps me also reminding things. It gives you an URL. And this is extremely efficient, especially if you're not working alone. Because then if you are working with PDFs, you have to download them, have a shared folder, who knows what that file is called, etc. While these tools have you like in a row, you have paper title and then URL. And if you share it with somebody, then you can just click on it and you access to the paper. It's extremely convenient. Also for your supervisor, if then you have a doubt, it's like, hey, where's the paper? It's just there. Yeah. Yeah. Yeah, so usually there is also an inclusion criteria we'll see later, which is the paper needs to be accessible, right? And you'll try the best to access to that paper. If not, then you have to exclude it because you can't access to that paper, unfortunately. So you try your best with you and your colleagues. If you have a way to finding it and you said, hey, I found it, this is the URL, whatever that URL is. And if not, then you have to exclude it. Mm-hmm.
On ResearchGate, similar to Zotero, but you can ask actually post to the authors if they can share the source of the paper. And in our experience, even if you send an email to the authors, most of the time they send you the paper.
I'm pragmatic. So whatever you have, if you have an URL to access it, I'm fine. But usually, as Patricia said, authors are very happy to share their research as a preprint. So it's not something which is copyrighted or just write. If you really can't find it in any way possible, you look at the darkest corner of the internet, you still can't find it, then you can write to the authors and they're happy to share it. Yeah, I know. Then you exclude it. Usually that's an effort. Kind of, there isn't like you shouldn't spend a year to hunt down a research and everything stops because you can't access to that research, right? At some point you have to be pragmatic about it, and it's like this is just not available everywhere, anywhere. It's just HTML title embedded in a dark corner of the internet. You'll do your best to find it. If you can't find it anywhere, then you'll have to exclude it. Mm-hmm. Yeah. And then yeah. No, no. Mm-hmm. Right. But yeah. I guess on Sci-Hub you have the peer-reviewed version. And even if you ask the authors, they won't give you something which, in most, sure, you have to trust them that they give you the. Yeah. Yeah. Generally speaking, you do your best to access a research in the peer-reviewed version of it. And I guess both if you use Sci-Hub or if you ask the authors for the paper, they will give you that version. So if you ask for a version and they give you another one, they're wicked researchers, right? So might happen, but I don't think that's a very recurrent scenario where researchers give you. A break already? Okay. So much things to say. Okay, I'll just have this little bubble here and we make a break. And this is a thing for later then. Ensure that your data extraction framework, so basically your table that you will use also for extracting the data, is conformant to the output of these tools. Nothing major. Usually you have something like title, year of publication, venue, author, and similar things. I'll show it just in a bit. And we have a 10-minute break. And afterwards, we'll see all the other steps. So how to extract the data, how to select the literature, how to extract the data, and how to report the findings in the end. Okay, thank you. So, use publish and perish. Selection criteria. That's going to be the next step. And this is a way to find the papers we're really interested. So to select the papers we're really interested on and get rid of all the other junk which we found via the automated query, right? The query. And this is because you have a lot of papers and you want to analyze them all, just want the selected bunch that you're really interested in. So you're trying to bring down the number of potentially primary studies to a reasonable set of primary studies. And how do you do this? Quite trivially, you use a set of selection criteria, we call them. We'll have the inclusion criteria, which usually are the semantic ones. It should be a paper about green and it should be a paper about AI. And then the exclusion criteria, which are the more trivial ones like I need access to the paper or the paper needs to be in English because I only understand English and Italian and German. And as a tip here, adapt existing exclusion criteria. We'll see this just shortly. So what could be the inclusion criteria for a study on green AI? You're already ahead of our mistakes we made at the beginning. So you should do a literature study. But what are the inclusion criteria, you think? These are the semantic ones. So the one that hold really meaning. Yes. Energy efficiency, sustainability. Yeah. Yeah, but what did you said previously? The paper should also. No, but before when you had the last thing you said was that it should be about the efficiency of AI and not the other way around, right? And this is why usually you have some rounds where you really grasp what you're doing and what you're looking for. And at the beginning, we're just, it's just it regards green, it regards sustainability, right? Trivial enough. But then after a bit, we started looking for the papers and then we found papers we were not interested in because it was about the thing you said previously. And so we had to tune it a bit more. And this was like after we just looked at 100 papers already, it's like, oh no, we have to go back and do this all from start again. But so as a general advice, it might be necessary to fine tune a bit these inclusion criteria to find really what you're looking for. And what you're looking for, you might understand only while you're doing this preliminary exploratory phase. So for example, we found that we are only interested in environmental sustainability because maybe some papers talked about the economic sustainability of AI. And we wanted to focus on the software level because idle software. So we found also solutions which were hardware. It was not something we were interested in. And as a tip, and this I learned the hard way because we're really quite in the selection, you want to crystallize this criteria as soon as possible because the later you do it, so the longer your exploration phase, the more time you lose in the end. So you might tune it, but don't tune them at the end because it will cost you a lot of time. Exclusion criteria, these are the syntactic ones, the more general properties that the primary study should possess. Not in English, because who knows, I was working with a Portuguese and a French lady, so we couldn't understand anything which was not in English because we had all to read those papers, right? Or the paper is not accessible to us because it's behind a paywall. Or we already included that paper in another version. It was a bit what we talked with Elias. Or we don't want to include secondary studies, so other studies which are doing the same thing that we are doing, basically, just the primary ones. We want things which are papers and not tutorials or books or whatnot. And the study should be a scientific publication, so peer-reviewed. Questions? Yeah. Yeah, that is a secondary study of sorts. You have different ways. In the software engineering domain, we mostly do this kind of systematic ones. But in other domains like networking, usually it's a renowned figure that just cites random papers he likes, basically. Like they have a lot of knowledge. They feel like they have a lot of knowledge and say, this paper is important, that it was seminar because this and that. So it depends, but these are all types of secondary studies. So they discuss the literature instead of being the basic bricks on which then the field evolves, right? Thank you. Tip here, you can basically copy paste this in most of the cases, slightly adapt them. This won't change that much. So usually this is where I do a literature study, then this, I start from here, and then if I have to tune them a little bit, I tune them. So maybe we want short papers, that's E5, could be, and exclude also short papers, or not, depending how many literature is out there. But this you can borderline copy paste and use for your literature review. Right, so if you are working in more than one, so literature, like the systematic hardcore literature reviews can take some time. So usually you have some collaborators to do the work together. And in this case, it's always important that, you know, you discuss what you're doing basically. You won't go that deep into it because maybe most of you will do a lightweight literature search and work alone. But if you're working with other people, always make sure you're all aligned on the same concepts, same wording. And there are also some statistical methods like Kibridov alpha or Cohen's kappa, where you can calculate the inter-rater agreement between you and your colleagues. Yeah, right, the URL part was there. And this is basically how you do the selection. Again, not rocket science. We have in green, in the green columns, the inclusion criteria, and in red, the exclusion criteria. What usually helps me is use emojis or whatnot to have like at the beginning, just you know what it is. What is I1? I guess AI. And what is I2? I guess green. I3 is it's the sustainability of the I and not the other way around. And I4, it's about software. I did this, I guess, 4 years ago. I see the emojis, I still kind of know hand-wavingly what they do. And they can even put comments and say, look, this E6, it must be peer-reviewed. And a paper is included if it satisfies all of the inclusion criteria and none of the exclusion one, right? Maybe I have a paper which is about green AI, but I can't access it. I won't include it in my literature review. All good so far? Snowballing. What is snowballing? Basically is you enrich the results you found with the search query. And how do you do this? Basically, you look at references. We have two types of snowballing. The backward one is looking really at the references which are written in the paper, so the reference section at the end, and you look there if there is anything interest to be included. And the forward snowballing, you basically go on Scholar or whatever search engine you want, and you look at the cited by. So forward because it goes forward in time with respect to when the article was published. And you do multiple rounds of this. So you have a set of primary studies you included with the selection criteria. Then you look at, for example, all the references in those papers. And this is one round of snowballing. Then this will allow you to find new literature on when you will do the snowballing again. Right, so you will include for each round a new set of primary studies till you reach theoretical saturation. Theoretical saturation is when you can't find any new papers to be included. This hand-wavingly usually happens around the second or third round of snowballing. So you look at the references, it's just all the same ones you saw before, nothing new to be included. You have a good probability that you found most of the literature of the topic you are studying. As a simple tips, when you do the snowballing, snowball the papers in a forward manner and backward at the same time. So basically, I open the PDF, I want to snowball, I look at all the reference lists, go back and look at all the papers that cite them. That makes things more faster than with, I just do the forward snowballing for all of them, then I have to go back to the paper again and do the backward one, for example. In this phase, it's easy to include papers you have already included. So always make sure to check. I'm including a new primary study I found with the snowballing. Do I have it already in my primary study list? There's Control F on your sheet where you have all the hits and look if it's already there. And this might be very time consuming. So again, this is something that if you're doing systematic literature review, you want to talk with your supervisor if you find a high number. I guess due to time, we can skip. Okay, we can have a few examples. So this is the backward snowballing. So this is a reference section on a study that we were doing on Green AI. And so, for example, is 8 a study I would include in backward snowballing? My study is on Green AI, remember? Number 8. Who thinks it should be included? No. Why? It's not AI, it's not green. But for example, I can already tell that 19 and 20 will be included, right? One starts with sustainable AI, and the other one starts with use of machine learning for improvements in performance and energy. There it is, right? And it has machine learning and it has energy with high probability. Same thing, exact same thing with forward snowballing. This is the cited by section from Scholar, right? Under the title, you find a little link. This can be very time consuming, as I said. This is just as an example. This is a real sheet we used in the study. And the attention I want to pose you is on that little number there. This is the size of one paper, and it says 986. So here we're really doing the systematic hardcore kind of study. And say like, wow, this is like 1,000, so we better split it up. That was reviewer, was Rob, that's me. And then you had other people looking at the sites. And where you want to cry is when you see, okay, there are other ones like this. So it's very time consuming. Pro tip here is discuss this with your tutor. If you do a systematic and you find 1,000, maybe you want to discuss with whoever's supervising you and say, hey, I have to look for 4,000 papers, maybe something is going in the wrong direction, right? So don't over-sacrifice yourself on this. The data extraction is the next phase. So after we do the automated query, we do the selection on these papers to find the ones which we're really interested in. Then based on those, we snowball them to have a wider set of papers which we're not able to find with the automated query. Then we have our final set of primary studies. These are really the data, the ground data from which we're going to extract the results we're interested in, really. And this is just data labeling. I mean, an SLR is not only data labeling, but this phase is data labeling. So the goal here is to extract the data from the primary studies to answer our research question or to have a mapping of a research field. And how you do this is a two-step. In the first one, you define what data you need to extract. And this is done via a data extraction framework, we call it. Nothing more than an Excel sheet with some columns that tell you what to extract. And then you analyze each paper to extract, to label the data which is contained in it, according to your data extraction framework. So what is the data extraction framework? Is just the glorified Google Sheet or Excel sheet, whatever you're using, that you can use to systematically extract the data from each of your primary studies. The trivial fields which you usually have there and the Zotero publish and perish already downloads for you neatly is the paper metadata, right? So where was it published? When was it published? What is the title? Who are the authors? This kind of information you already have for free. And here just a little bit of jargon. We define an attribute as basically a data field. For example, publication year. For each paper, I have the attribute publication year, and then this attribute can assume different values, right? For example, in case of publication year, I can have 2003. And this is what really it looks like, right? So we have trivial fields, venue type, conference or journal. We have a year of publication. There's also a trivial field. And then we have how to define, for example, green AI, or what topics does the paper cover, data-centric and precision energy trade-off. And this is basically the part of data extraction where you say, you have a representation, let's say, of the content of the paper according to your data extraction framework. Right, so how to define basically attributes? Attributes sort of, how can I put it? They define some characteristic of the paper, and this characteristic usually is mapped to one of your research questions. So how do they define green AI? Could be the first research questions, like what is green AI for the research? And then you have a definition of that. And usually you have different research questions have a certain number of underlying attributes. Then you aggregate to have a simple question to answer to the research question you have. And how to define these values? You use a coding process. A coding, basically, it's another way of, say, data labeling. Coding is used a lot of also in qualitative research, where basically you attach a keyword to a certain concept. And each attribute follows a different coding strategies. We'll see just a few now. So how to attribute, in general, the goal of coding is to define a certain number of values an attribute can take. For example, yes or no. Do they have an industrial author? And then their values are yes and no, simply. Which coding strategy you use depends on the attribute. So of the nature of the data you're trying to extract. Common coding strategies are open coding. I just attach a keyword to a concept. For example, in case of green AI, could be deep learning. I don't know, which type of AI do they consider? And then an open code could be deep learning, another one could be machine learning, or whatever you please in this regard. Then you have provisional coding. So we start from a predefined list. I guess in a certain sense, the year could be defined as provisional coding because we have all possible years, and then we just attach one of those labels we already have in our minds. And magnitude coding instead is basically attaching a value from 1 to 5. How big was the data set they used for the machine learning algorithm? And this is magnitude coding, right? So it's used to define things like presence, frequency, intensity, size, likelihood, etc. Think of Likert scale, basically. Anything which has discrete values is magnitude coding. I usually suggest this book. I guess you can find it online. Don't read, I mean, you can read it all, but where it's interesting is just Appendix A, where it gives you a rundown of all possible coding strategies, and you can say, feel really fancy and say, oh, I did magnitude coding for this attribute. And as a pro tip here is, at some point you will have to finalize your coding. So the codes usually you take a while to understand all the possible values an attribute can assume. But after that, you should try to keep it fixed. Because if you find a new attribute at the end of your research, you have to go through all papers again to see if that new code is also in those papers that you already analyzed. And this usually you do with your colleague or tutor, and it's like, hey, I found a new attribute now. Is it really important? Yes, no, and then you'll have to redo some things or not. Provided this information alone, which codes would you use to describe this paper? We want to extract data from this. I mean, I'll help you with this. This is quite easy actually, because what we're doing in this process, so usually don't extract data from the title alone. We see this just now, but basically the semantic parts here are for sure data-centric. Green AI, it was a paper on green AI, so I don't have to note that down. A study on, okay, sure. Training precision. Training is another keyword. Then I guess precision energy consumption trade-off is another keyword. So here, yep. Yeah. We didn't look at it actually. Too late. Yeah, thanks. So basically, you try to understand the really most semantic parts and say, okay, this is for sure some data-centric, training precision energy, the trade-off I will analyze, maybe that they look at energy consumption and not other metric. I think that we looked at. Yeah. And this is basically open coding, and then sure, you have green AI definition, energy efficiency. We already understood from the title where they were going. Solution type, study type, solution. This might not be clear, so we have to read the whole paper to understand this. Topic, data-centric, and energy precision trade-off. And this is basically the and training was also in the title. For other information, then you will have to read the paper, of course, which you do after you selected them. But just from the title alone, we could already have a good idea. And then maybe the topic, the labels there, which are separated by comma space, came from an open coding. So we didn't have the list at the start saying this is going to be the term data-centric. We just found at some point that, hey, this is important, we should include this. And then from there on, we had this new label to attach, went back to the old papers. We looked if it was anything data-centric and so on. And this is a bit the process of data extraction, right? If you're working with somebody else, usually you subdivide the papers. This in general, you do some exploratory rounds on the primary studies, on some primary studies to understand where you're going basically. So what data you can extract from the papers, what is interesting, what is not. And usually, as said, new codes emerge as you go, right? So data-centric was never a thing before. I found a paper on it. I will now have this new code in my data extraction framework. Constantly compare keywords, not only if you're working with somebody else, but also when you're working alone, because there might be a code you have already used that is very similar, and maybe you want to work a bit with other codes to just change it and include also the new concept instead of having a new code and doing everything from start again. So this is called code homogenization. So you want to keep them cohesive throughout the whole data extraction process. So basically, are we saying this, or am I saying the same thing differently, right? And this might be a bit hard because it's sometimes like, but what did they meant with data-centric? They're doing database energy efficiency. Am I just saying the same thing? And this takes a bit of getting used to also. So also always look back at your codes, saying, does this new code can be expressed in one of my existing codes, or should I create something new? Should I split up a new code? Should I merge two different codes? And this is part of the code homogenization process. This is usually a rookie mistake, which is how to read a paper. Generally, this is something that you get accustomed to as you read more and more papers. You don't read them from start to finish. I would say I'm quite effective in reading papers, but basically you kind of have a feeling of where the information is. So you look at something, it's like, oh no, you open the paper, you say, yes, no, I found what I looked for. And this is useful in general as a skill, I guess, how to read a scientific paper. But basically don't read it from start to button, but do with the paper what you want to do with the paper. I'm looking for the implementation of an algorithm. I open the paper, I look for that, I understand it, I close the paper and I'm done. And I'll start introduction, related work, yada, yada. So in general, keep in mind, you shouldn't read each paper from start to finish. This also is true for the selection criteria. When you apply the selection criteria, you want to, as fast as possible, understand if that paper is in or not. And when you've done that, you close the paper and go to the next one. Could be from the title alone, right? If you have a doubt, then you look at the abstract. You have still a doubt, you look at the conclusion, and so on. And then there is this paper which sort of gives a bit of a rundown, especially the first part, on how to skim through the paper quickly to understand, to find the data you're looking for. Yeah, I mean, don't overdo it from start. It's like, oh yeah, I found it. Get accustomed with your own speed of reading papers. So start slow, and then as you see that it works for you, you can start to accelerate and be faster in extracting information from papers. Right, so start slow, yeah. Basically that. Constantly could discuss doubts, of course. That's especially if you work with other people or if you have a supervisor and it's like, hey, but should we also include papers which consider how AI can improve environmental sustainability? And then you will find sort of your scope of the research also in this phase. And work towards the right level of attribute granularity. This is always a point which is a bit tricky. So if a value is repeated too often, so it's like if every paper is about green AI, maybe it's not that interesting because every paper I included in my study was about green AI. So I can remove that data extraction piece because I just lose time by tracking something which is obvious. Or if it's repeated too little. So if you have a nice bar chart and the column other takes all 90% of the paper, then maybe I want to abstract a bit more so that it can have a better overview of the topics which are covered in those papers, right? So in this case, for example, if attribute values are too numerous, I just have one column other, then I try to merge the different attributes in some super values. So maybe instead of looking for a specific deep learning algorithm, because everybody uses their own, I just say, are they using deep learning or they're using machine learning or AI? And yeah, as general thing, an attribute could have more than one value for a single attribute in a paper, right? So for example, when we saw here, topic, it has multiple ones, right? So it's not that it has to be one topic exclusively. It could be that according to my data extraction framework, I have different labels to express what is really covered in that paper. Yeah, so finding the correct level of abstraction is really important. You might tend to have some super values which cover them all, but actually it's about finding something which is interesting and at the same time is feasible while doing the data extraction. Highly suggest to use a standard convention to write codes. You can even use the drop-down list on the sheets where you have some predefined values and you really add the new ones. So for example, you always use snake case or lower case, whatever you like most, to avoid the typos or, oh, this express the same thing. Energy precision trade-off had a minus, you put an underscore, now we have two codes. This kind of thing. Possibly, if you have a definition of all attributes while you go, It's a good thing to do, especially if you're working with other people, so you know exactly what everybody means with deep learning. If you're working with people, and also if you ask feedback from your supervisor, usually what works is highlight where you have doubts. So it's like, this keyword might be in or not, I put it in yellow. And every time I go to my supervisor, I have the yellow things I want to discuss. Systematically, very efficient. Keep notes. So in some cases, you want something, you have a doubt, and you want to discuss it with somebody else, note it down immediately when you have a doubt, because otherwise you will forget, and then the quality of your literature review goes down. And yeah, as said, avoid to include new attributes towards the end, because you will have to redo all the other mapping. Data synthesis, it's not the simplest thing ever. I guess it takes a custom also to report, not only to extract the beautiful data, but a big part of a job is also to know how to report things, not only to do, maybe the data is beautiful, but then you report it in a very messy way. It looks like the study is not good. So overall, the goal is to summarize and combine the extracted data. And maybe you want to choose which data you want to present. So another thing which maybe junior researchers often fail is to find also the right level of granularity in reporting the results. You don't have to tell everything. You want to tell what is interesting. And here you can have data visualization, statistical analysis, and scientific writing as basic tools on how to report a work. And here in the specific case of systematic literature reviews, attributes are clustered in sections, right? According maybe to your research question. And each attribute, basically each column, has a different subsection. It's quite easy. Which attributes could be used to describe a publication trends? We saw this is stored in the metadata. And it's things like maybe publication year, overarching topic, and venue. Usually you have these. Data visualization, due to time, I won't go through all of these, but you might know them. And usually there is some data which you can borderline map one-to-one to some plots, some data in the SLRs which can map one-to-one to plots. For example, if you have a year, how much a topic was studied, then you will usually have a bar chart, right? Or if you want to show cross-reference between different attributes, you can use bubble plots. If you want to show industry involvement, you can use a Venn diagram. Sankey plots are nice, but very complex to be read. So it is just if you want to feel fancy, but not let anybody understand what the data means. Tree map charts are just glorified bar charts. If you want to feel fancy about not having a bar chart, you can have a tree map, and then it looks beautiful. In general, the tip here, try out different layouts of the data, and then the one that conveys the message you want, because that's also right. Data visualization is not about showing the data, is to bias somebody in telling what to look for in that data, right? So maybe here's like, oh, look, cloud provider and software service provider, how many they are. Other tips, provide a quick and univocal definition of all attributes when you start. So it's like, hey, when I say deep learning, I'm saying this. Use fraction and not percentages. This is usually something we do. So 10 out of 50 study do this. Consider all attribute values while describing the final results, and use some examples because they're nice. Like this was from the AI study. Just to have a bit of a breath of fresh air, right? So, for example, would I'll provide a landscape of the carbon footprint of AI models across Facebook. Sounds interesting enough to keep me going reading, right? Instead of just reading numbers and say, this many papers focus on carbon footprint. Use boxed environments. Or I think you've seen this before. Use two separate sections of, actually, I'm gonna skip this and this, okay, maybe just this. There is this nice package to split up references between the references and the primary studies, which is quite helpful. and it looks neat. So you can really differentiate what you reference in the paper and what you use as data for the literature review. We're going to share the slides anyhow, right? So I'm skipping a bit of stuff. Use a structured abstract. There is an SLR template, which you can access to, and this also helps a lot in structuring the report, also because a lot of stuff is basically already there. So no need to write it down. And with, well, it's not showing. He's upset that I put it there, but with a colleague, we wrote a paper on how to write papers, really accessible, and you can, it gives you a bit of rundown of what has to be written in each section. So it means like how to write the results. Okay, just open that, read how to write the results and do that. Further insights into literature search, just a few words. The different methods. We saw a systematic literature review approach. Other ways are you just do the snowballing. So your tutor gives you a set of papers and you do the backward-forward snowballing for them. Or you might focus on a specific venue. Let's look what the International Conference on Software Engineering did on software testing in the last 10 years, maybe. Cherry pick primary study could be that your supervisor says, these are the papers you need to study, would also be the case. Or semi-systematic literature review. Usually these are actually called rapid literature reviews, which is a way in which you can conduct in a very fast way literature reviews that usually you just scope down the set of primary studies via different strategies. Could be limiting the search strategy. So for example, I just look at the last year, what happened in software testing in the last year, or I just look what happened in the last year of software testing in the automotive domain. I don't know. Use a single literature indexer, especially if it's not Scholar, because that contains a superset, but maybe just look on Scopus, and that already brings down a lot the number of primaries. Or if you have a single researcher, it's also one of the properties. In most of the cases you will, but just to give you a bit of a more comprehensive definition of what the rapid literature review is. And these are usually done in collaboration with industry on a specific problem. So let's look at software testing in the automotive domain in the last year. Okay, and then after a couple of months, you come back and you have a 1-2 page briefing where you can really tell to your industrial partner what is happening in that domain. Again, don't do this choice independently. I guess your supervisor knows best on which of the approaches is more fitted according to your specific goal, situation, interests, etc. There are many things I didn't talk about, like gray literature studies, so looking at non-peer-reviewed content, multivocal literature reviews, which include both white literature, so the peer-reviewed one and the non-peered one. Paper quality assessment is something that some people do. And there are many SLR methods out there. We just presented ours. There is even SLR meta science. So people that, like me a bit, do this also from how can we improve the situation and what is, for example, tertiary studies, they study secondary studies. So it's a literature review of literature reviews. And this is something you can do if you say, how do people do literature reviews in a certain domain? Or there are researches on how to do specific steps. How do you do snowballing better? How do you primary study quality assessment, etc. You can have new SLR methods such as this I presented here, and have bibliographic research, like how many, who are the most cited people, why, and how. So I guess this was just, I hope, a simple process that you might use, also just portions of them. It's not said that you will do the whole rundown of the method, maybe just do the snowballing, and you have some tips to do that. Slides will be available. And this ends the lecture.